So section 4-5 is on simplifying algebraic fractions, and this can throw kids for a loop, so we'll take it slow and we'll try to do some examples both here and in class. Before we even get to algebraic fractions, let's just talk about simplifying regular fractions in simplest form and what all that means. And so here I've drawn a pie, and I've cut the pie into 12 slices, and you can see that I've colored 9 of them in green, so 9/12 of the pie is in green. But if we didn't want to cut the pie into 12, right, we could just cut it into 4 slices. You can see that, this slice is red, this slice is red, and this slice is red, and the other slice is not. So seems like 9/12 and 3/4 are the same, right? So if we didn't want to draw a pie chart every time, how might we get from 9/12 to 3/4? Well, I think you're going to say, well, just divide the top and the bottom by 3, right? You're right, we can do that. So 9 divided by 3 is 3, and of course 12 divided by 3 is 4, and so 9/12, right, equals 3/4. Another way to think about doing that is to do some prime factorization, right? So for the 9, right, that would be 3 times 3, and for the 12, that would be 2 times 2 times 3, right? And can we cross anything? Do we see anything in the numerator and the denominator that we could cross off? Sure, we could cross off the 3's. What does that mean we're left with? Well, we're left with 3 over 2 times 2. 2 times 2 is 4, okay? And of course, 3/4 is in simplest form. And what does simplest form even mean? Well, let's kind of investigate that for a second. So the definition of simplest form, right? A fraction is in simplest form when the GCF, and the greatest common factor of numerator and denominator, is 1. Well, that's kind of a fancy definition, right? Fraction is in simplest form when the greatest common factor of the numerator and the denominator is 1. That kind of makes sense. If I look at 9/12, right? 9/12 was not in simplest form because the GCF of numerator and denominator was 3, but 3/4 is in simplest form because the GCF of numerator and denominator is 1, right? Okay. But how do we get there? Well, basically what we do for step 1 is that we primely factor the numerator and the denominator, and then we cross out or divide by common factors. So that's what we did above, whether or not we realized it or not. Well, let's check that out, right? Because we started with 9/12, and we said, okay, 9 primely factored is 3 times 3. 12 primely factored is 2 times 2 times 3. And we looked for factors that were both in the numerator and denominator, and we crossed them out, and that's kind of what it means to divide both top and bottom by 3. And we just keep what's left. And what's left here is 3, so that's 3. And what's left down here is 2 times 2, that's 4. Okay? So we can do this with harder ones as well, and we can also do it if there's a word problem. Let me give you an example. So what if the problem said 88 feet is what part of 1 mile? Okay? Well, there's a couple things you need to know to do this problem. The first is that 1 mile is 5,280 feet. You definitely need to know that. And you probably need to know that part here really means fraction. Okay, well, simplest answer is, well, 88 feet is 88 5,280ths of a mile, right? Because it's 88 feet over 5,280 feet, but they probably want that in simplest form. And it doesn't look like the GCF of 88 and 5,280 is 1. For 1, both are even. Okay, so at the very least, we know we could divide top and bottom by 2. But let's follow our steps, right? Step 1, I'll remind you, right, is to do the prime factorization. So prime we factor, right, numerator and the denominator. So let's do that. It'd be a little bit of a pain, okay, but 88 is, let's see, I think it is 2 times 2 times 2 times 11. Okay, and if you didn't know that, you should do your factor tree, okay, because it's 8 times 11, then 8 is 2 times 2 times 2. Okay, and just for the sake of time, I'll tell you that 5,280 is 2 times 2 times 2 times 2, how many 2's? 1 times 2 times 3 times 5 times 11. Now you could do that with a factor tree, it would just take you a minute, okay? So step 2 is to look for the common factors. And those we can cancel. So I see a 2 in the top and a 2 in the bottom. I see a 2 in the top and a 2 in the bottom. I see a 2 in the top and a 2 in the bottom. I see an 11 in top and 11 in the bottom. Okay, well, there's nothing left in the numerator. That doesn't make it 0, right? That makes it 1. And all that's left to do is 2 times 2 times 3 times 5. And of course, 2 times 2 times 3 times 5 is 60. So my fraction, which is now in simplest form, is 1 over 60. So 88 feet is what part of a mile? Well, it is 1/60th of a mile. Okay, and you can see what we did. Now, this section was entitled Algebraic Fractions, and we haven't even gotten to an algebraic fraction yet. So let's look at one quickly. An algebraic fraction has variables in the numerator or the denominator. So what if the problem said to simplify 21x squared y over 35xy squared? Okay, well, our same two steps are going to apply, right? So for the numerator, okay, 21 is 3 times 7, so 3 times 7 times x times y. Okay, 35 is 5 times 7 times x times y. And now we're going to look to see if we have things that we can cross out, okay? My 7's are gone. And again, think about what we just did. We just divided top and bottom by 7, okay? In reality, we divided the fraction by 1, which is part of the identity property. The x's can be gone, the y's can be gone. That seems to be about it. What's left? 3 times x, so 3x. What's left down in the denominator? 5y. So this is that fraction, 21x squared y over 35xy squared, in simplest form. Why is it in simplest form? Because the GCF of 3x and 5y is 1. There's nothing more that can be done. I'm not going to do this right now in the interest of time, but I did want to tie this into the rather confusing end of yesterday's lesson, which is this idea of being able to factor an expression, right? So in the previous problem, we simplified 21x squared y over 35xy squared. I've got the same things here, except I put them side by side. I put a plus sign. And what if I said factor them? Well, we're going to do the same thing in that we're going to identify the GCF, right? And the way that we can do that is by doing the prime factorization. But instead of crossing out the GCF, we're going to pull it out, right? So remember we wanted GCF and then we had stuff left in parentheses. See if you can figure out how to do this, where this, if you're motivated to, where this is the GCF, whoops, just as the CF, and then what's left, maybe you can figure that out too. Ask me about this and we'll do this one in class because it's kind of fun.